Hi, good evening. Today we're going to be reviewing some of the material we did from last week's class. And in that class we talked about unifying multiple classes together under what's called an interface. And then we were also able to use that to build some new data structures. And in this particular video we're going to be talking about building something called a stack. Okay, so I guess the first thing we should do is review something about a stack. If you recall, if you've ever heard of a stack before, you know that the stack has a couple of fundamental operations. First of all, what is a stack? A stack can be viewed as kind of like, well, if you think about maybe a stack of plates at a cafeteria, you can do things like add a plate to the top, or you can take a plate away. And so adding a plate is called a push operation, and taking away a plate is called pop. So there's two operations you can do on a stack. You can push an item onto the top of the stack, or you can pop an item off the top of the stack. Okay, so we have push and we have pop. And so traditionally, you build a stack out of something like an array, and in fact, you can think of this as being just an array, maybe with the number 0 element here being at the bottom, and then you add things to the stack by essentially appending them to the array as you go. However, we got a problem here. Is in Java we have fixed size arrays, so we can't just automatically extend them as the stack gets deeper and deeper. So we need some kind of array that extends itself, and we happen to have one in the form of a class called ArrayList in the Java standard library. So ArrayList, let's take a look at the documentation for that. So this is the ArrayList, and we can see that it's generic. It's an array list of some kind of element, and they call it E in this case. And it's got some methods that we've seen before. It has things like add, oops, let me go back to the list here. It's got things like add, it's got clear, contains, get, index of, what else do we have here? Remove, set, size. Those are methods that we've written before in our course, and those are all provided for you in the form of this ArrayList class. And this is just like the one we wrote. It automatically extends itself as you need. So as you add elements to it, it gets bigger and bigger and bigger. And then if you take elements away, it actually doesn't get smaller. The underlying data structure doesn't get smaller, but it just subtracts 1 off of this size so that it always appears to be exactly the size that you need. Okay, so we can build a stack out of this. Essentially, when we do a push operation on the stack, all we're doing is adding to the array. So we'll just call the add method with our thing that we want to add to the array. And then when we want to pop something off, we're just going to call, remove. And then we tell it, in this case for ArrayList, we tell it which index number we want to remove. So we want to remove the last item off of the list. Okay, so that sounds pretty easy. So it looks like for stack, what we could do, so here's the whole purpose of this particular video, is how do we implement this stack? So one idea is maybe we can just say extends ArrayList. So basically our stack takes the existing ArrayList class, and we're just going to add on a little piece to it. So to use the ArrayList, we need to say import java.util.ArrayList. Okay, and then in here we can just go, let's make this generic, so let's go T. So we're going to go void push T value, and then we just got to say add value, and then we're done. And then for pop, we'll say that it returns a T, and so we'll say T temp equals remove size -1, so that should remove the element off the end. Then we'll say return. Let's see, does remove actually, I got to look at the documentation for that. remove, yeah, it returns the thing that we're removing. So actually we can just say return the thing that we're removing. Okay? And that's essentially stack right there. Let's see, return, remove, Java cannot return to T. Oh, we need to do that. There we go. So remember, whenever you're using a generic class, you need to make sure you use it in the generic form every time you use it. So if you are creating a new class that takes in a generic type T and then uses an existing class, you need to make sure you pass that value along to the existing one. All right, so let's try it out. So let's say we've got a stack of string, and let's call it S. Okay, so s.push hello. S.push, let's put another thing in there like bonjour. So can I make this bigger? There we go. And then if I go s.pop, I get bonjour, which is the last thing that I pushed onto the stack. And if I go s.pop again, I get hello. And if I pop one more time, I get an array index out of bounds exception. So I've just popped too many things off of the stack. Okay, so essentially we can build stack out of an existing class like ArrayList. But there's a serious problem with our implementation, and that is this. If we go s.push, let's put hello back on there. And let's push hola. Okay, we can go s.size and find out there's two things on there. Here's the problem, is because I told you earlier that stack only has two operations, push and pop. And those are the two operations that I defined here. I defined push and pop. But because stack extends ArrayList, it can do everything that an ArrayList can do. So that includes being able to get, size, toString, set, insert, delete. And in fact, we could go s.set 0, adios. And then if we go s.pop, we'll get hola, and s.pop again, and we'll get adios, not the hello that we originally pushed onto there. And so this is a problem with our implementation, that stack extends ArrayList, and so it can do everything that an ArrayList can do. And we really don't want someone who's using a stack to be able to go in and modify, go in there and like modify some of the existing entries. It should only be able to access the top. And so the reason for this is the way we've defined it by saying class stack extends ArrayList is we just established what's called an is-a relationship. What we're saying is that a stack is an ArrayList. So anything that ArrayList can do, stack can also do, because stack is an ArrayList. And that's not really what we want to do here. Let's see, let's switch to another screen. Okay, so if I can kind of draw this picture here, here is ArrayList. Let me actually, yeah. I was going to say, let me move that. Just put it more in the center of the screen. Okay, and it provides methods like add, remove, get, size, toString, clear. Okay, and inside of ArrayList, let me again move this up here a bit. I need a little more space. Inside of ArrayList, there are some private variables. There's probably an array sitting inside there. I don't know what it's called, but let's just call it ARR. And it's some kind of array. And there's also an integer keeping track of how many elements in that array are actually valid. Let's call that the length. Okay? So the whole purpose of providing these methods here is to give us sort of windows that allow us to modify these private variables, the array and the length, without actually being able to touch them directly. In other words, if I do an add, what it's going to do is it's going to modify this length variable here. It's going to put a new entry into array and possibly extend it if we need to. When I do remove, all it's going to do is subtract 1 from the length here. When I do something like a get, it's just going to reach into the array and pull the value out. Okay, so but the whole point of having these methods is to hide these internal variables and provide controlled access to those variables. Okay, so ArrayList boxes this whole thing up, and then kind of, if you will, it puts these little windows in the side. Okay, and these little windows here allow us to kind of look inside, get access to these methods here, but not be able to look at this stuff up here. So that's the whole point of having the methods, is to provide controlled access to the internal variables. If we didn't care about having access to the variables, we'd just make these public and we'd forget about writing methods. We'd just group them together in a class and then just make them public. But we want to control access to it, not only to only allow the user to do certain things to them, but also to make sure that they can't mess around with it in a way that they're not supposed to. Okay, so what we've done by making stack be an array list is we've essentially said that everything that stack can do, ArrayList can also, everything that ArrayList can do, stack can also do. So stack can add, stack can get, stack can toString, and stack can clear, and that's not what we want. Remember, the purpose of having these methods here, let me reiterate this again, the purpose of having these methods here is to hide these variables so that people can't access them directly. And so what we want to do is we want to essentially make another box around this. And we want to call this stack. And then we want to provide a couple of methods, push and pop. And then just like before, we'll open up little windows here. And the purpose of having this stack class is to hide the array list that's inside of it and only provide access through these methods, push and pop. Internally, the stack is going to call add and remove and any other methods it needs for the array list. But by wrapping it up inside of a box, we're going to say we're going to protect the array list. Just like the array list protected the individual array and the length variables, the stack is going to protect the array list and only allow us to access it through these two methods. Okay, so earlier I said that stack is an array, and that's not the relationship we want. ArrayList, what's its relationship to array and length? Clearly we can say that ArrayList is not an array, nor is it just a length. Instead, we can say that ArrayList has an array and a length. Okay, so this relationship is not an is a relationship. This is called a has a relationship. An array list has an array and a length inside of it. Okay, so by extension, the stack has an array list inside of it and provides these methods. Okay, so a has a relationship means that a class is built out of these things, and an is a relationship means that it just extends that thing. Okay, so within the array list, I'm sorry I'm bouncing back and forth between these two examples, but within the array list, this array and this length are set up as being private variables that only the methods can access. So we want to set up our stack so that it has an array list. Okay, and so the way we set it up is exactly the same way we set up these. Anything that's a has a relationship becomes variables within the class. So again, here's our stack, here's our array list. We want to set up a has a relationship, so we need to make our array list be a variable within the stack. Set it to be private, and that way no one outside of the stack can get access to it. So let's switch back to the computer. And let's not have it extend ArrayList. Okay, let's instead have it have ArrayList inside of it. And let's call this ARR. Okay, so our ArrayList is inside of the stack. And let's make it private so that no one on the outside of the stack can mess around with it directly. Okay, we're going to need a constructor. And what the constructor is going to do is it's going to make a new array list of t. And then our push is just going to add to that array, and our pop is just going to remove from the array. Okay. And how did I mess up that? Oh, I didn't pass in the t here again. There we go. So I have to remember, every time I use array list, I got to put the angle brackets after it. Okay, so our stack now has an array list inside of it called ARR, and then the push and pop just act on that variable. We also need a constructor in order to build the empty array list. And let's see if it works. So here's our stack, and we'll go s.push hello. So it works like before. Push hola, s.pop returns hola, s.pop returns hello. So it's working as we expected. And let's try to do s.clear, which was something that the array list could do, but our stack shouldn't be able to do. And this says, I can't do that. If I try to do s.set, oh, let's push something on there. S.push, let's push hello back on there. If I try to do a set of 0 and change it to adios, I can't do it. There's no method called set inside of the stack. So we've taken the array list and we've hidden it inside of the stack. And so as far as the user of the stack is concerned, it can only do two things, push and pop. And the user of the stack just looks at this first line here and says, okay, I've got this thing called a stack, and I really can't tell from the declaration of the class itself how this stack is built. Is it built out of an array list? Is there an internal just array? Is it doing something magical where it's somehow just adding things to a stack? Is it literally a stack of plates? Who knows? And from the users of the stack's perspective, who cares? Okay, that's what we're trying to do here, is we're abstracting away the idea, the implementation details about how the stack actually works, and making something that just works the way it's described. Okay, so the user of the stack doesn't need to know there's actually an array list back there. All right, so that's building a stack out of an array list. Now, if you've studied the array list a little bit, you know that the add operation for an array list is pretty quick. All it does is it just adds one element onto the array and it's done. Modifies the length also. But occasionally, the add operation is really expensive because the array's gotten full, so it has to make a new array that's slightly bigger, copy the values over, and then put the new element on the end. So when that expansion happens, the add operation actually takes a significant amount of, well, I wouldn't say super significant, but it does take an amount of CPU time that's sort of directly proportional to the size of the array. So if there's 1,000 things in the array and we've got to grow it, then the number of operations we have to do is on the order of about 1,000 things. But usually the add is really quick. We only have to maybe put that element in and then change the number, so there's only 2 things to do. But once in a while, it's really expensive. And so there's another data structure out there called LinkedList that works faster for doing operations on the end of the list. So if you want to put something on the beginning of the list, it's really fast. If you want to put something on the end of the list, it's also really fast. And it's constant time, which means it always takes the same number of operations, regardless of how many entries are actually in the list. So that's called linked list, and it's already in the Java library. And so to modify our stack to use a linked list so that it has a linked list instead of an array list, we just got to modify this. Linked list, and then change this. And I think that's it. All right, and it compiles just fine. And if we use our stack, let's put hello on there. Let's put goodbye. And then if we pop, we get bye. And if we pop again, we get hello. So it's working just like a stack. And all I did was I changed linked list here, and everything else was the same. Okay, I didn't have to change add because it so happens that linked list has an add method, and it works just like ArrayList's add method. It puts something onto the end of the list. And remove works exactly the same way. You tell it where you want to remove something, and it pulls it out of there. Okay, so it happens that linked list is optimized for working on the ends of the list, either the beginning or the end of the list. Okay, so we're able to swap one for the other. We're able to take the array list out and put in linked list. But here's what I want you to realize is that you, as the implementer of the stack, get to choose what kind of performance model you want. Now, the downside of using a linked list is there's more memory overhead. You got to maintain a forward pointer, and you got to maintain a backwards pointer, and you probably got to maintain pointers to either end of the list because it implements a doubly linked list. So there's more memory to be used. Instead of just storing one element in an array and keeping track of how long the array is, now we've got to keep track of not only the element, but also 4 pointers. Pointers backward, forward, and front, and the head and the tail. So by using linked list, we're going to use more memory, but we get faster access. By using ArrayList, we're going to use less memory, but it's slower once in a while. So I'd like it so that as the implementer of stack, I can kind of choose which one I want. So I could either say, this is going to be an array list, or it's going to be a linked list. Now I'm going to have to recompile the program either way, but I really want to write this so that I only have to kind of change what kind of list I'm using in one place, right here where I got it highlighted. And so what I'm going to do is I'm going to say that stack is just a list. Actually, I think I need to say abstract list here. And that's not working. Actually, let's go look at the documentation. So here's ArrayList, and it says that ArrayList is derived from something called abstract list, which is the thing that I was just trying to use, abstract list. Here's linked list. This one is also derived from something called abstract list. There's also abstract sequential list in there, but there's abstract list. So you can see they share them in common. Okay, see that there? So let's try to use that. Import java.util.abstract list. Okay, this compiles. So what's the type of our array? Our array is of type abstract list. But then we go when we say it's a linked list. So you'd think that there's actually a type conflict here, that array is being assigned to something called a linked list here, but its type is actually abstract list. And the reason why this works has to do with going back to the is-a and has-a relationship. Oops. Okay. So let's see, let's switch back to this screen here. So we said that a stack is an array list. In other words, it does everything that an array list can do. So the way that our program is going to be set up, the way the program is, or the way the Java utilities are set up is linked list is an abstract list. An array list is an abstract list. So they're both kind of tied together. All right, so here is abstract list. And here is array list and linked list. And they both go back to this one here. So array list is an abstract list and linked list is an abstract list. And that means that both of them are compatible as far as types go because they have the same parent type. So let's go and take a look at abstract list. So I just click on it. It says that this is a class called abstract list. Oh, and here's what I was actually looking for. This thing called an interface called a list. Let's try that. Let's just say list, and we'll change this. Ah, it works. That's actually what I wanted right there. Okay, let's go look at list. So list is this thing called an interface. Okay, and what an interface does is it just says everything that is a list has to provide these methods. So if you want to be a list, you have to be able to add, you have to be able to clear, you have to be able to get, you have to be able to do index of, remove, set, and a bunch of other things. Okay, so an interface says that if you want to be one of these things, these are the behaviors you have to do. You have to be able to do these things. If you don't, if there's one of those missing, you're not a list. Okay, so here's how it works. And I'm gonna make a new class here. Let's make this class. Let's say you are designing a video game, and there's a couple of different or a few different kinds of things on the screen. There's a player on the screen. There's the enemies that you're trying to shoot down, and there's also obstacles that are in the way. So let's say you define player. Okay, and for now, what you're doing is you're just thinking about what are the kinds of things that my player needs to be able to do. So my player needs to be able to, let's say, public void move. It needs to be able to move. And for now, I'm not going to worry about the, well, let's go integer amount. Okay, and let's just for now just have it say system.out.println moved amount spaces. Okay, that's all it's going to do. And our player also needs to be able to, let's see, it should be able to move, and it should be able to shoot. Shooting, okay. And our player also needs to be able to die. We'll go ugh. Okay, so there's our player. Okay, and then I say, okay, I also need an enemy. So what is our enemy able to do? Well, our enemy is able to shoot. So public void, is able to move. Let's say an amount. So moving plus amount plus spaces. Okay. And our enemy, let's say, yeah, our enemy can shoot also. Enemy shooting. Okay. And obviously our enemies can die, right? Sole purpose of shooting them. All right. Okay, so essentially now you realize that we've got player and enemy. They're defined almost identically, right? A player can move, a player can shoot, a player can die. An enemy can move, an enemy can shoot, and an enemy can die. Okay, so exactly the same three things. And so now you're thinking, okay, I need to make a game, right? So let's call this game. Okay, and then my game is going to have some kind of arena, a board that they're going to play on, but more specifically onto that board goes my players and my enemies. So I need to make an array. Actually, I'm going to have one player, right? But I'm going to have, actually, maybe multi-players. Maybe you can have multiple players, and obviously you're going to have multiple enemies. So you need to make an array, and I think we should use an array list. So let's say it has a private array list of player. We'll call this players, and it has an array list of enemy. Okay, and then we have a constructor. Players equals new array list of player, and enemies, new array list of enemies. Okay, and then let's go players.add new player and enemies.add new enemy. Okay, let's just one player, one enemy for now. And then I ought to be able to start having them like shoot each other or something. So let's just say, let's just write some loops. So we'll go for int I equals 0, I is less than players dot size, I plus plus. Okay, players dot get 0 dot shoot. Okay, and players dot get 0 dot move 5. Okay, and then we'll do the same thing for the enemies. For int I equals 0, I is less than enemies dot size, I plus plus. Enemies dot get 0 dot move 10, and enemies dot get, oh, that shouldn't be, sorry, this shouldn't be 0, this should be I, right? I dot die. All right, so there's my game. And I need to import java.util.ArrayList. All right, and so the purpose of my play method is just kind of to exercise the players and the enemies. Okay, so if I now go game, g equals new game, and I go g.play, then we see the player shooting and move 5 spaces, and then we see the enemy 10 spaces, and the enemy dies. Okay, and this is actually left over from our previous example, so we'll clear the whole thing out, and we'll run it again just to show that why didn't we, well, okay, okay, so shooting, move, 5 spaces, okay. I think that's okay. All right, so now we want to add on something called obstacle. Okay, public class obstacle. Okay, what can an obstacle do? Well, an obstacle can't move, but let's say an obstacle can shoot, right? It's in one position, it can shoot stuff out, but it itself can't move. So public void shoot, system.out.println, obstacle shooting. Okay? So now, in my game, I want to add obstacles to this. So I need to add a new variable. Let's call it OBS. And then OBS equals new ArrayList obstacle. And then I'm going to go obs.add new obstacle. Okay, and then my loop, I'm just going to cheat and copy and paste. Okay, but my obstacle can't move. All it can do is shoot. Make a dead Boolean. Yeah, well, we'll get there. All right. So you can see in my game, I had to, in order to scale it up to add a new thing, I had to add a new loop. I had to add a new array list. I had to add one new of everything in order to get this to accommodate my new type of thing. And so really, what you kind of realize after a while is that a game just consists of stuff on the screen, and the things on the screen have certain behaviors. Like players can shoot, move, and die. Enemies can shoot, move, and die. But obstacles can only shoot, and that's it. And so what I really want to do is I want to kind of unify as much of these things as possible so that I only have to make one array list of things. Okay? So what we need to do is we're going to do essentially what ArrayList and LinkedList does. We're going to make an interface that describes what things on the screen can do. So we'll say interface there, but you don't have to actually check that box. What should we call this? We should call this an actor, let's say. So something on the screen is called an actor. Okay, we'll go public interface actor. And in an actor interface, we're going to describe that all things on the screen can do. And so you look through your classes of player, enemy, and obstacle, and you go, well, the only thing that all of them can do is shoot. So if you're an actor, you have to be able to shoot. Okay? So we'll say public void shoot. Okay, and that's it. No body, we just put a semicolon on the end, which says that anyone who's an actor must have a method called shoot that looks just like this, public void shoot, no parameters. And that's it. If we compile this, it's going to work. And then inside of player, we say it implements actor. So at the very least, it needs to provide a method called shoot. And now it compiles. And then for enemy, we'll do the same thing. Implements actor. Okay, and then obstacle. Implements actor. Okay, and now let's see, this diagram gets a little complicated, so let's move things around a bit. This is good, good enough, I think. Okay, well, the important thing here are these arrows, which says that enemy implements this interface, player implements this interface, and obstacle implements this interface. Okay, and then my game here, I can just say I have an array list of actors. And get rid of all this stuff here. Okay. what do we got here? Actor. Okay, and then in my play, all I got to do is say actors dot add a new player, and actors dot add a new enemy, and actors dot add a new obstacle. And then I can get rid of all this stuff. All right, so let's compile this. No errors. Okay, so I've got now, instead of 3 separate array lists, one for players, one for enemies, and one for obstacles, I've got one array list for actors. And then I can add in all these different kinds of things that happen to be actors. So a player is an actor, so I can add it to my actors list. Enemy is an actor, so I can add it. And obstacle is an actor, so I can add it. And then I'll just loop through all the actors and tell them all to shoot. So if I make my game, and let's bring up the terminal and clear it so that I'm not seeing anything I shouldn't be seeing. And now I need my other window, which is behind here. Ah, there it is. Okay, so let's go g.play, semicolon, and there's the player shooting, the enemy shooting, and the obstacle shooting. Okay, so that's kind of cool, is I've just made my game a whole lot simpler by just having one array list that holds all of the things in my game. And that's all because of this is-a relationship. The player is an actor, the enemy is an actor, the obstacle is an actor, so I can make one list of actors and then add them into there. Okay, but what about the whole moving and dying thing? Okay, so players can move, enemies can move, players can also die, and enemies can die. So what I want to do is I want to make another interface for these things here. And I want to show an interface that has more than one method in it. So I don't want to make one interface for things that can die and one interface for things that can move. Let's somehow just put them all under one interface. So let's call this Moveable. Okay, and so we'll say that things that can move can also die. How about that? So public interface Moveable. So things that are movable need to provide a shoot, a move, and a shoot method. No, a die method. Yeah. Okay, so if you are going to implement the movable interface, you need to provide these two methods, move and die. So we'll compile that. That works fine. And then in player, we'll say it implements actor and movable. And so Moveable says you must provide a move and a die method, which are there. And enemy will also implement Moveable. And that works. And now in my game, I can just say for int I equals 0, I is less than actors dot size. Okay, and this is actually not going to work so well. Actors dot move 5. Okay, and this is not going to work. And the reason this is not going to work is because my array list consists of actors, and as far as the compiler is concerned, actors only know how to shoot. It doesn't know that some of these actors also know how to move and die. So this is where my analogy breaks down a little bit. We actually need to now create an array list of just the things that can move, and then we can write our loop to go and exercise those things here. But what I wanted to show was that the whole idea of interfaces is to take a common set of functionality, move them into this interface, and then have everything that has that functionality implement the interface. So let's see what happens if we make a new class. So let's see, we have players, we have enemies, and we have obstacles. What else could we have in there? Maybe we could have we could have another thing in the game called a friend. So a friend maybe is an automatically moving character, but it's your friend, it's not your enemy. Okay, here's our friend. And so what should our friend be able to do? Well, our friend, let's say, should be able to move. Our friend should be able to, let's say our friend can move, and our friend obviously can die, but our friend doesn't shoot, okay, for some reason. So that means that we only need to implement the movable interface. Okay, so our friend can move, our friend can die, but our friend can't shoot. So let's see what happens if we compile it. And we get a message at the bottom that says, friend, ignore this part here, friend does not override method die in Moveable. This error message is telling us that we need to provide a method called die because we're implementing the Moveable interface. So if we go public void die, and then we go system, let's just have it print something out, system.out.println friend dying. Okay, and we compile it again. It says friend does not override the method called move. So the compiler is telling us you want to be a movable thing, you've got to provide a die and you've got to provide a move. System.out.println friend moving. Okay, and now it compiles. Okay, but friend, unfortunately, is not an actor, so it can't be added into our game inside of the actor array list. But at the very least, you should. What I was trying to show there was, if you make a new class and you have it implement a method, then the compiler is going to make sure that you do implement those methods. It actually won't let it compile if you don't implement all the methods that are listed in the interface. Now, you can actually supply some of your own. Let's go public void name, and we'll just have the friend say, actually, let's make this a string. Return amigo. Okay, so we can ask the friend, what's your name? And it's always going to come up with amigo. But you see, it compiles just fine. So friend implements movable. It has to, at the very least, provide these two methods, but it could provide some others as well. So down here, we could say friend f equals new friend. We can go f.move. Oops, I'm sorry, move 5. And we get a message that the friend is moving. We can go f.die. And we see that the friend is dying. We can go f.name. And it returns amigo. Okay, so just because you implement a method doesn't mean you only have to provide those methods. You can, just because you implement an interface doesn't mean you only have to provide those methods. You can also provide some others. Okay, so this is the idea of what's going on inside of ArrayList and LinkedList. The Java standard library is providing an interface called list, and it's saying that anything that implements the list interface has to provide these methods. And if they don't provide those methods, they're not a list. And so that's why both LinkedList and ArrayList have a very similar set of methods: add, remove, clear, size, index of, contains, and so forth. And that's also why in our stack we were able to say that our stack contains some kind of list, but we get to choose when we compile it whether it's a linked list or an array list. So we can change this to array list, and it compiles. We can change this to linked list, and it compiles. Okay? So when you want to have two or more classes have a common set of behaviors, make an interface. List out what those behaviors are. All you have to do is list out the first lines of the methods, just the return type, the name of the method, and any arguments that it might take, semicolon, and that's it. There's no actual other code inside of an interface. And then have all of the classes that have those common sets of methods implement that interface. And the compiler will make sure that you provide all of those methods. If you don't provide any one of them, it won't compile. You can provide extras, but you have to, at the very minimum, provide the ones that are listed in the interface. And this allows you to essentially simplify all of the, simplify anything that uses those classes, because you can make one, let's say, data structure that holds anything that implements those particular interfaces. This is actually how the entire Java standard library is built. I mean, if you take a look at things like Windows, you go like, well, Windows have certain behaviors, like I can move a window, I can close a window, I can make it bigger, I can give it a title, and a lot of those things end up as being interfaces. There's an interface that says a window, let me back up a bit. So in addition to Windows, there are things like dialog boxes, which are kind of like Windows, but they're just the ones that say, like, an error occurred, click OK or cancel, right? It's a special kind of window. It's not a window that necessarily has a scroll bar. It usually has two buttons on it, an OK and a cancel, so it's a different kind of window. And yet, you're still able to move it around. You can give it a title, but you usually can't resize them. So they're just like a window, but not quite. And so what happens in Java is there is a class called JFrame, for our standard window, and it implements an interface called resizable. And it says that if you're something that can be resized, you have to provide a method called resize, or set size, or get height and get width. For things like the dialog box, it's not resizable, so it doesn't implement that interface. And so it doesn't have to provide a method called resize. What else do we got here? Well, so a JFrame is just a thing that you can put stuff inside of. It just contains things. And so actually there's another superclass called container, which is just a thing that holds things. And the internal contents of a window is a container. A scroll bar is a container. It's just a container that contains this gray thing here. Here's a container over here. Menus are things like containers. Buttons are containers because they contain the contents there. And so all containers basically can contain things, but not all of them are resizable, not all of them are scrollable. So there are interfaces to implement all those things. If you are a scrollable container, you need to provide a method called scroll and maybe one called set position or something like that. If you are not a scrollable container, like a button, then you don't implement those interfaces. Okay, and then what that allows us to do is do things like create, you can have this in window here just be basically an array of containers, buttons, scroll bars, menu bars, this thing over here. So it doesn't matter what types of things those are, you just know that this window contains stuff that contains other things. So there's this giant class hierarchy. There are basically all interfaces and classes that implement those interfaces. All right, so that's kind of an overview of two things. One is how a stack is built out of either an array list or a linked list or anything that is a list. And in fact, we could find other things that are lists. Like it says here that list is implemented by abstract list, sequential list, array list, linked list, vector. Oh, and there's stack. There is a stack built in. And so we could find other things that have this same set of methods by following the hierarchy down. Okay, and I also showed you how interfaces are built to begin with. You find classes, you define your classes, and if you find that you have classes with methods in common, make an interface and have those things implemented. All right, it can simplify how you structure your program overall. Okay, so I think that's what I wanted to cover tonight. We got a couple people watching, so if you've got any last minute comments, go ahead and post them now. If I don't see anything in the next 30 seconds to a minute or so, then I will bid you good night for now, and I'll see you next time. Bye-bye.